Your dinner is held together by physics you didn't ask for, and it's working perfectly. You think you're holding a cardboard square. You're actually gripping a lightweight truss system engineered to survive the modern supply chain. Let's autopsy the box. See those ridges? That's corrugation geometry. Each flute acts like a tiny I-beam. When you stack 3 boxes, the axial load travels straight down the flutes. The flat liner boards take the shear stress. It's load distribution so efficient that a cheap lunch outperforms most office furniture. Stop crying about crushed slices. That's just bad stacking technique. Now, thermal efficiency. Cardboard is basically trapped air. Air is a terrible conductor. That's why your pepperoni stays hot long enough to actually burn your tongue. But here's the bottleneck. Trapped heat breeds moisture. The box fights a losing war against steam. It's a thermal compromise. You want crispy crust or a soggy bottom? Pick your poison. Engineers call it vapor management. You call it lunch. Then there's the fold, that scored crease. It's a fatigue crack waiting to happen but controlled. The manufacturing process scores the fibers just deep enough to bend without snapping. You're looking at predictive stress modeling in a cheap box. If you overfold it, you get a permanent crease. That's structural fatigue. But you just shove it in the passenger seat. Spec the crease. Flat pack logistics. 1982. Engineers realized storing assembled boxes is just hoarding air, so they collapsed them. Volumetric efficiency hits 95%. You're shipping empty space, not product. That's why your order arrives with 4 spare boxes in the bag. It's not greed, it's spatial optimization. Rigid packaging companies still haven't figured it out. Skill issue. This is the masterclass, controlled structural compromise. The box isn't meant to last forever. It's meant to survive the trip, hold the grease, and fold back into oblivion. It's anti-consumer by design. You pay for the pizza, not the packaging. The box fails on purpose. That's not a bug, that's a feature. But wait, the vents. Those little triangles cut into the side, they're thermal relief valves. Steam builds pressure. Pressure makes crust sad. The cuts equalize the vapor differential. It's fluid dynamics in a lunch container. Ignore them and you get a sauna. Use them and you get a slice. Don't overcomplicate it. Then comes the final boss, the passenger seat. Torsional rigidity meets urban potholes. The box experiences lateral g-forces, sudden deceleration, and aggressive lane changes. The interlocking tabs lock the geometry. No glue, no tape. Just friction and geometry doing the heavy lifting. It's aerospace-grade packaging for a $2 extra. Meanwhile, premium industry is out here using molded pulp and recycled plastic that takes 40 years to decompose. You're getting grease-stained brown rectangles that biodegrade in a compost bin. You're winning. The nostalgia isn't just the cheese pull. It's the system working exactly as designed. Critics say corrugated cardboard is obsolete. They want rigid, sealed, zero-waste luxury boxes. Newsflash, that's just weak design thinking. You're optimizing for shelf appeal, not utility. A pizza box isn't a museum piece. It's a disposable load-bearing vessel. If your packaging survives the delivery driver, it's doing its job. Argue with the physics. I dare you. So next time you crack open that greasy square, remember, you're holding a triumph of chaotic engineering. It's flawed, it's temporary, and it's absolutely brilliant. What's the most over-engineered thing you've ever eaten in packaging? Drop it in the comments. I'll read them while my pizza sits. And yes, the crust is getting cold.